Hello all. Today we will see this last practical, which is hierarchical clustering. Specifically, we will see agglomerative clustering. Now for doing this, we required one package called hclust. So I'm writing this install.packages hclust, which will install the package hclust. Next, we need to load this package. So we are loading using library. So library hclust. Then we required one data set. So today we are taking this US arrest data set. You can take any data set. Now this data set contains crime that has occurred in various states of America for different uh, arrest that has been occurred for different crimes in the states of America. Now we are storing this data into one frame called DF US arrest. I'm running this and you can see here data frame has been created which contains 50 observation and 4 variable. You can view this data frame by clicking on this, and these are the various states here. Okay, these are all the states and these are all various crimes that has occurred, and this shows various arrests that have been done for all these different crimes. Okay, so that is your data set. Now we need to pre-process our data set. So we need to do pre-processing. Okay, so if you want, you can do pre-processing on your data. So if it requires, then you can do. So basically, pre-processing we will do only removing the NA values. Remove NA values. Okay, for doing this, we require one function NA dot omit, right, which will remove all the NA values. So we have seen this function before, and inside this you need to pass your data set. It is DF, and I'm storing this again into DF. Running this. Now I have removed all the NA values if there were any. If it wasn't there, but still I've shown you how to remove the NA values here. And then next thing, you can scale your data, right? So scaling, or we can say normalizing, or we can say standardizing. Okay, anything you may say. So scaling we normally performs because when we have large difference in between the values, then if we use those data as it is, then it may produce a false result, right? And that we don't want. And for avoiding that, we are doing this normalizing or scaling. Okay, now how you can scale? So simple function is scale, which will apply scaling on your data set. Inside this you have to pass your data set. Okay, I'm storing again here this in variable, suppose D. Okay, so this is my scaling data, scale data. You can see if data has been scaled or not using this head command. So it will retrieve few records. So now the data has been scaled, right? Normalized. So this was pre-processing that we have done. Now we can apply this edge clustering algorithm. Now what we do in clustering, hierarchical clustering, is we find the difference between two. We take all objects at separate cluster, and then we find calculate the difference between two objects, and if they are closer, then we make one cluster of those objects, right? And this is how we combine different objects based on distance, and then we create different clusters. Okay, so first we need to calculate the difference, right? Sorry, distance. So we are calling this as D, where we are storing our distance. So you can use directly this dist, okay, this function where you need to pass your data set. So my data set is D, and then you can see here we need to apply supply method. So method, you can take any method, but by default we are taking this Euclidean, Euclidean, Euclidean distance. Okay, and that's it. Control enter. Invalid distance method. Dist D method Euclidean. That's it. बरोबर है. स्पेलिंग बराबर है क्या? ई, हाँ स्पेलिंग बराबर नहीं है. EUC. Okay. Okay. Now we have calculated distance using this Euclidean distance and storing it into D. Now we can apply this hierarchical clustering. So just type this hclust. So you can see this function hclust where you need to supply your data set and method for that. So we are passing D here. D हमें जो distance find किया है that we supply here, and then method is equals to complete single whatever, you can take any value. So I'm taking complete here. Okay, and then running this command. So this has created cluster. Now I'm saving this cluster into one variable called hc, running this command again, and now you need to create this dendrogram. Okay, so you can create dendrogram simply using this plot function. Inside this you have to pass this hc. So this will create the dendrogram, cluster dendrogram. Okay, this is the simplest method for creating dendrogram. Next you can supply how your data is hanged, right, below 0. What will be the height of your data set? So you can give the hang parameter here. CEX will be 0.1 and hang is -1. Okay, so this will show you more clearer dendrogram. Okay, so yeah, that's it for creating clusters and how you can show your dendrogram. Another way you can directly combine this to command. Okay, so I'm showing you second way you can create this H clusters, hierarchical clusters. So you can just combine these two commands into one. Okay, that's what I'm doing here. Okay, so hc is equals to hclust. Inside this, pass this distance, and we want to calculate distance for D. Okay, so this has the same effect as we have done here for this two command. Okay, so by default it takes method, distance method is Euclidean, and cluster method is complete here. Okay, and then you can plot again your data set like this, etc. Okay, so this is the same, these two lines are same as these three lines. Okay, so I've just shown you another way how to do this. Okay, and you can also create a dendrogram using as.dendrogram function. So let me just type this. For example, I want as.dendrogram. Inside this I can pass this cluster which I have created at C. Okay, now you can plot डेंड्रोग्राम. सो यहाँ पे आपको जैसे स्क्वायर में दिख रहा है. You can change the shape as triangular. So you just need to type your dendrogram HCD, and then type you can specify here. So type is equals to, let me show you type again. So type of plot, right? This will specify type of plot. So here you can specify triangle. Okay, so this will create a triangle shape dendrogram. Okay, so this is another way of showing your dendrogram. Okay, and then if you want to zoom into this dendrogram, then you can specify cut here inside this plot. Okay, so I am cutting upper part of this tree, dendrogram tree. Okay, using this cut, and inside this I am passing my HCD, and I need to specify height h equals to 75, suppose, and I want upper part of this tree, so I'm supplying dollar upper. Okay, so this will show you upper part of this dendrogram. Okay, similarly you can have this lower part using lower command. So I'm copying this again, and if you want you can uh, go to any specific branch of that part. Okay, using indexing. So suppose I want to branch to I want second branch, so I will write 2 here inside this. Okay, so this is this shows your lower part of the dendrogram. Okay, so that's it. So this is your last practical. I hope you all of you understand this. Okay, and if you have any doubt for this or anything related to practical, just message me. Okay, thank you all.